maybe few are joining who are absolutely fresh and new to the concept. So we will try to build up the concept, and basically in our the full-fledged course, that is our job ready training, we go into much details, much depth in cloud. So you will have lots of 80% of hands-on. Okay, so that way we build up the skills. But here, because the scope is limited, I can only go for a little bit of hands-on, but morely focused. The ratio is just the reverse over here. It will be 80% of theory and 20% of hands-on. Let's see how far we can go with this. Let me share the screen. Let me start the recording first. Oh, the recording is started already. So, yes, Mr. Menon, is the recording started for Teams?
Yes, it started.
Okay, okay. So I can share my screen. You will please let me know if you can see the screen.
Yeah, we can see your screen.
Okay. Now let me share my camera as well. Am I visible? Okay. So let us start having a concept of cloud. This is the most important topic when we learn DevOps, because without knowing the cloud, because our tools are all designed, we carry on with our main course over onto our cloud, which is AWS. And so it is very imperative that we know about cloud, how this architecture will help you. Basically, over whenever you will be working in any organization, you would be working on any platform which is cloud. It can be AWS, it can be Azure, or it can be a hybrid as well. Okay, so let us see. Okay, I will have my pen ready. And let me expand my screen. I hope you can see the screen. Okay.
Yes, we can.
So this is the AWS Cloud, Amazon Web Services Infrastructure Essential. It is basically an infrastructure over the cloud, a bridge, which is an infrastructure without having any pillars. Like the bridge is intangible. You cannot touch that bridge, but the bridge exists as if is it on the cloud. So what is cloud computing? Who is using cloud computing is a very general topic. We may skip this part. We are already aware of cloud. What is cloud computing? It is an on-demand delivery of IT resources. The resources are existing on the cloud, or you may create the resources over the cloud. Okay. So whenever it is on demand, whatever you demand, you will be getting, as if it's like a door-to-door delivery. You can be in any part of any corner of this world. You are now having the power to harness the power of the cloud. That is, sitting in a particular corner of the world, you can be working very remotely in your company and using an access. I'm in India. I'm working from a remote area, and I will be able to access with my company, who is a global company working in, let's say, some head office is in US. So all these things are very possible. It is because of the cloud technology. So it is pay as you go pricing. Like it is like your electricity bill. It is your telephone bills. Okay, you can make a prepaid payment, or you can be there can be a postpaid training as well, payment as well. So whatever it is, it will not exceed of what you have used. So it is as you pay as you go, or you pay as you use, sort of a technology. So the thing is very reliable, and it is up to you to plan out your usage. You can avoid investing a lot of capital money on elephants or like big servers and everything, but you are using only 20% or 30% of the capacity. It should not be that case, and that was the case earlier. Okay, where big companies used to invest billions and millions of dollars on the network infrastructure, on the software, I mean the architecture, on the storage part, on the server part, and lots of money. But in practical terms, they were using only a small part of the entire capacity. That should not happen, because that is only you are keeping your money on hold. You are not basically optimizing the investment. So the return on the investment was too low. Whereas now you are investing a little bit of money and you are harnessing a lot of outcome or output from that particular thing. Because the pricing over the cloud, because there are lots of competing brands of cloud over this internet in this computing world. So therefore, the pricing is very, very competitive. So it is to the benefit of the users or the benefit of the customers who are accessing the cloud resources. So it is much good to the company, because they don't have to cut down on the human resources. They don't have to sack people. They can save money by going to the cloud. So that is a big saving. So who is using the cloud computing? Organizations of every type. It is not necessary that you will always have to use all the services provided by the cloud. No. The cloud can be providing you hundreds of services, but you may be selective in getting those services. Okay, like some company is having a lot of problems in their storage. Okay, they can go for a cloud service called the cloud service. The cloud AWS cloud will provide a lot of software. I mean the storage options. It can be a huge storage problem, or it can be a small, like S3 bucket. You can have a small storage, simple storage, like an S3 bucket, and you can have a glacier type of a storage, which is you can have the truckloads of data. You can transport from one country to the other country without physically transporting the data. It is you are taking the help of cloud. But those are lots of discussions. We will do it in details. So the requirement of any company could be, any organization could be data backup, or data basically, disaster recovery, email, virtual desktop, software development and testing, big data analytics. Now for this big data analytics, you need a server, which is, if you go for buying on your own, so it can cost you a lot, because those servers are very powerful. It has to be very, very powerful, because you cannot, with the help of ordinary computing resources, you will not be able to do a big data analytics. Okay, so you go to cloud and get a service of a particular size of a computer, of a server, which suits your data analytics. So that is also very, this is very much in practice. Then your customer facing web applications, for example, the healthcare companies, mostly the healthcare companies, like I'm in India and I am consulting a doctor over in US for a critical illness of mine. Okay, everything is over the virtual world. I mean, the doctor appears to me as if I'm talking in my same place, or the scanning and everything will be done over, even the tests and the test results are automatically and very fast available to you. So those are the things that the healthcare can very much use the cloud computing resources over the cloud. Financial companies, definitely, like you are you are a stock broker, or you are a trader over the stock, on the stock, your, New York Stock Exchange, and you are somewhere, some part of the US, and you are doing that. So you do not need to be present uh, at that particular office to be doing that job, but you can do it at your home, at the comfort of your home. It is all the financial services companies are using the cloud services, the real time fraud detection and prevention, the video games and all those stuff. So many applications of cloud. You may not stop going through the list. Now the benefits are huge. First of all, it is the agility. That is why we prefer the cloud. Agility is the agility in the deployment of your services. Because see, today's world, you have a lot of competition with your competitors coming in huge numbers. So there is no innovation. There is innovation. There is no novelty. The novelty goes off within a few days or within a few weeks. You will always find a competing product has already come into the market. So better is if I can deploy it as the customer needs. Before the customer needs, I should be available with my product. So be available in the market just in time, JIT. And to do that, you can use your cloud services. So deploying a technology over the cloud is in a matter of minutes. It is like from ideation to production. So the concept is you do some ideation, which is the starting of an idea. So your ideation to production. Every stage of what Karthik was saying, now it was SDLC, software development life cycle, and you say secured software development life cycle, whatever it is, either SSDLC or SDLC. So to do it over the entire cycle of ideation to production, you can use the cloud services. All of the cloud services can be in place. So what basically you do is to deploy your services to in production. Okay. So that is one big agility part that you do. Now the elasticity. What is elasticity? Can anybody have an idea? Can any one of you volunteer yourself to let me know or let us know about elasticity? What do you mean by elasticity? In physics, you have a topic called or a chapter called elasticity. Why we are discussing elasticity over here, and especially that topic of elasticity is well defined within AWS, because most of the AWS services are with elasticity, like Elastic Cloud Computing, which is a EC2 server, EC2, Elastic Cloud Computing. Why it is called Elastic? Anyone?
It's
Yeah.
not delivered.
I'll say something.
Yeah, sure.
It's quite elastic because, as you said, EC2 instance.
Okay.
It's a resources that can be scaled up and can also be scaled down based on the workloads of that resources. So you can shrink, you can expand that using not cloud things, but using cloud things. It's what you can scale it up and can also scale down based on the workloads of the resources.
Exactly. To manage the workload, you cannot be very stubborn. I mean, I am a big server. I can only cater to this many of requests, and I'm not flexible. Yeah, this flexibility, this elasticity is what you want, because in your legacy system, the flexibility and the elasticity was missing, very, very missing. Okay, so that is one thing very important. You should not pay more than what you have used. Like in Christmas, you have a peak. It's a peak season or a peak time when there will be a lot of business. So your servers will be too much busy. So at that time, you may have provision. Provision means you have created or you have afforded or you have made an infrastructure which may not, you didn't expect that much of spike in the usage, but it can. So you have to think of that particular situation where out of expectation there was a lot of usage of your application or your resources were used too much. There were too many requests coming in for accessing your application. So what you do is you should be in an infrastructure which can automatically expand. That means there can be a horizontal expansion or there can be a vertical expansion. Vertical, this is called scaling, vertical scaling or horizontal scaling. You can keep on adding servers to cater to the demand of the resources. That is by horizontally adding more and more servers. But otherwise, if you have configured your auto scaling in such a way that if you think up to a threshold level, you can manage it by vertical scaling up. That is, you keep on adding CPUs, the memory, the space, the storage, vertically. That means the server remains the same, but you are keeping on adding the more CPU, more. So you are adding the instances, not instances, the sizes. You are applying the sizes as and when up to that level where you have kept your threshold. And once the threshold is above that threshold, that means now it cannot go beyond that particular threshold of a particular server. You go for the second server. That is horizontal scaling. So all these things can be automatically configured, and your cloud will be behaving as an elastic, like you can expand it, you can shrink it. When after the Christmas, when the sales come down, when the business loses the peak levels, then what should happen? You should not be, whatever the scaled up resources you have, you should not be using them or paying for them. Rather to say, you should not be paying for them because they are not being used. So what it should do, it should automatically scale down as per the demand. That should happen automatically, auto scaling. And that is provided as a service with cloud. Cost savings, as I told you, cloud will always allow you to have lots of tariffs or plans, the price plans, okay? And you can select the best suitable price plan for your company or for your usage. So it will be a lot of cost savings. You can't believe how much of cost savings it can provide you. It can bring a lot of good to the company's health of monetary situation, financial condition of the company can vastly. Otherwise, it would have kept on investing on the OPEX and the CAPEX. CAPEX is the capital expenditure and OPEX is the operational expenditure. Okay, so more and more CAPEX you do, more and more OPEX will go up. So they are interrelated. But here, you do not do that. It is up to the cloud and your configuration, how you configure your requirement. After that, that will be automatically scaled up and this thing. So it will do a lot of cost saving. As I told you, the thing is deploy globally. Not only deploy, it is deploy globally in minutes. So there is no visas. You do not need a visa to go from India to US or go to India to Africa, okay? Or coming from Africa to India. No visas, because cloud has provided you no barriers between the regions, okay? So every country is a part of a global village where you do not have to do all those. There are no latencies. Basically, to say that there is no latency between when you traverse, your data should traverse very fast, and your application should be available within minutes to every corner of the world. That is possible through cloud. Now, this is the basic. Your applications will be catered with the AWS. The services are available for each and every layer. These are the foundation services. This is the application and platform services. And these are management and administration services. We in our course generally go for all the services on the foundation services and all the services under the management and administration services, barring the CloudWatch. CloudWatch is mostly for the operations guide, like somebody was asking in the cybersecurity session about the monitoring, about like the SRE. Okay, the SREs and the operations team will come to this part mostly. Okay, so in that case, Amazon has a beautiful product called CloudWatch. So if you have gone for anything like Splunk or Nagios or Prometheus or even for the Grafana, Kibana, okay, so those are also monitoring tools. But what I will suggest is if you pay a little bit more, yeah, but it is far less costlier than Splunk. Okay, so many customers or many companies are going for using Amazon CloudWatch instead of going for a heavy duty product like Splunk. So that is mostly on the operations part. And this part, this application platform services, we as a DevOps engineers are not particularly developers. We are not from the development background. Yeah, we may have idea of languages, development languages, but actually we are not in a role of development. So this entire row, these services are meant for our developers, okay, who are developing on the cloud. Like the content distribution is one of the important factors, and you can use a service of, these are all services. These are all services for your applications development. The cloud front is one of the very important service for developers. Then there is the messaging, because the developers do a lot of queuing and messaging. So they can use these services, Amazon SNS, Amazon SQS, SES. Then there is also a part of search, or you have a lot of applications having a search engine. Okay, so you can incorporate this service, a cloud search. Then there is Elastic MapReduce and Amazon SWF. These are particularly the services. Can you see how much Elastic? See, AWS Elastic Beanstalk, Amazon Elastic Cloud Computing, Amazon Elastic Block Storage, Amazon Elastic Cache, Amazon Elastic Load Balancing. So can you see Elastic, so many places? And that is because of Amazon is very fond of using this term, because they are really giving this feature of elasticity a lot with lots of their services. Okay. So cloud search, Elastic MapReduce, this is for distributed computing. Like this is the content distribution, and this is distributed computing, like serverless computing and all those stuff. You can do it with MapReduce. Then there are definitely all the libraries for the most important and most popular languages like Java, PHP, Python, Ruby, and .NET. All these libraries are available within the platform services. So you can use the libraries and SDKs, software development toolkits. Now the foundation services are, as a DevOps engineer, we must know all these services. As well as, of course, we have to use the Amazon Management Console, AWS Console. We have to use the identity and access management for federation. Okay, that is for your users, and the role-based, because your applications is, and for the security purpose, you should have a role-based access control. And for that, you need, that is called, a very popular term is called RBAC. Now, RBAC everywhere. Even when you learn Kubernetes, you will see a lot of role-based access control. Your role is very important. You will have only the access to those resources according to your role. So you will access so many resources, but you cannot access all the resources. It is based on the role-based access control. So basically, this identity and access management that is called IAM will help you to have groups where you assign the policies, okay, and then assign the users, IAM users into the group. So say a person joining the HR department or somebody joining the IT department of a company. So do you think they will have the resources access to, HR will have resources access and the IT will have access resources? Will they be same? It cannot. Okay. So an IT guy cannot see the payroll database, a database which is payroll. So only the HR guy, and that too also not all. Maybe the accounts manager can only under the HR, or the HR manager can have an access to the payroll, not the IT guy. But the IT guy will have an access to, say, some data which is used for data analytics. Okay, data analytics, and they do not have any business with this database or this data, particular data for this service. So they are federated and they have to be role-based. And that will be implemented through this service called Identity and Access Management. So compute resources, which is your server. This is your server. You will create your servers on using this foundation service called compute. And then you can configure auto scaling for your servers. That is, whether you want to go for a horizontal scaling or a vertical scaling or horizontal scaling. Now, that is configuration through the auto scaling feature or the service of Amazon. Amazon S3. S3 is a simple storage service. Amazon has a knack for going in abbreviations. So S3 is 3 S's. Elastic EC2. EC2 stands for Elastic Cloud Computing, because it is part of the computing or compute resource service. So without these servers, you cannot start. So, but here it is EC2. There are 2 C's. Elastic. Similarly, for the storage like Elastic Block Storage, which is like your GP2 or GP3, which is nothing but your SSDs. SSD, you know, those solid state device, which is optical devices, storage device. And then there is a big storage called AWS Storage Gateway, but these are all from the storage services. So if you have terabytes of data that you have to import or export, you will use storage gateway. Say for big telecom companies like AT&T or Vodafone, or in India it is Airtel, so or O2 or Hutchison. So all these are big companies who are going to give you provide the telecom services. Now they can generate terabytes of data, terabytes of CDRs. CDRs, you know, the call detail records or call data records, whatever you can say. The CDR, every CDR can be generated. So within seconds, you can reach terabytes of data. Can you believe? And there is a mandate that for any company like the telecom company, they have to keep each and every call for 7 years. Can you believe how much of data, petabytes and petabytes of data, 1,000 petabytes of data will be accumulated over even in a month? So how will you archive them? So to archive and store the data for 2 years, for 7 years, is a huge Herculean task. Okay, so even the big companies do not have the infrastructure to store such a huge amount of data. So they can go for AWS storage gateway, and there is Glaciers and so many other technologies. Okay, so you cannot imagine how much data capacity that can be generated and how much the storage solution can be provided by Amazon. Coming to the database, like there are database administrators. Now, the database administrators were very costly. And you have to have a lot of dependency on the database administrators. A medium-sized company can hardly afford to sustain 2 DBAs in a company. Medium-sized company is a big company, but they would find it very difficult to have 2 DBAs, database administrators, because they are too costly. Now, with Amazon or with any cloud services, you have the solution. You go for their services like Amazon RDS, Relational Database Services. Okay, and you can get away with this, the cost of this 2 guys. A DevOps engineer will be enough. Yeah, with some sort of a knowledge on database, a DevOps guy can also manage on behalf of the company if you have gone for a service like AWS RDS. Okay, or DynamoDB. DynamoDB is like no SQL database. See, for a relational database, it is an SQL database. SQL is structured. You have a table which is having rows and columns. It's a 2-dimensional table, row versus column, and your data is on this intersection between the rows and the columns. Yeah, all this data. And each row will represent one entity fully. It can be an employee, it can be a product, it can be anything. So it will define the entire entity fully. So that is a very structured way. So you can call or retrieve the data, you can read, you can create, you can update, and you can delete. So it is called CRUD functionality. CRUD. Create, read, update, and delete. So all these things can be done through SQL calls, because it is a structured way of defining your data. The schemas are all structured, whereas there is also this coming up technology called NoSQL. That means this is restricted, constrained, whatever you may term it. It is not flexible, whereas you need some flexibility, and you need a lot of flexibility. So you go for NoSQL like MongoDB. So in the MongoDB is a NoSQL database, and this when you implement that on the cloud or you get a service from Amazon, you do not need to be a MongoDB specialist or a NoSQL database specialist. As a DevOps engineer with some little knowledge of a database, you can very well manage this, because most of the things it is like a SaaS, software as a service. We are coming to that. Okay, so it is a software as a service. So everything, there is the managed service. So you just have a little bit of knowledge on database, and especially a NoSQL database, and you will be able to manage. You do not need to go for a costly DBA. So why a company is hiring you? Because you are the champions of all these things. You can save a lot of money for your company. That is why people are looking for, even if you are not very much deep into your knowledge, but you can somehow, and you have enough knowledge to manage the cloud-based services, because 80%, 80 to 90% of the job is already managed. You have to do 20 to 10% of work. Okay? And elastic cache, like you have, Redis. Okay? So these are the memory cache management tools. So you want to have your memory databases in memory, which are very, very fast in operations and all those stuff. So big data or Hadoop, or like say, where you manage the big data, will use this particular technology a lot. Amazon Elastic Caching, memory databases. Then we come to the networking. And under the networking, we will learn about VPC, Virtual Private Cloud. Any of your cloud or any of your region, which is, we will come to regions, availability zones, edge locations. Now, those regions have a VPC, at least a VPC, a default VPC, Virtual Private Cloud. Without this, you will not be able to host your servers, storage, databases, you name it. Any of the services will not work without the region having a VPC. Even the storage that you are creating, the S3 service, S3 bucket, you can say a bucket. A bucket is a place where you can store your files and folders and images and photos and whatever. So most of this is a very, very popular service. Many companies are only going for only Amazon S3 services. They have not gone for all of this. They may have only gone for this. They are only paying for S3 services. That's all. Okay. So their developers are putting all their files and storing it over here. Though it is not a version control like the Git and the GitHub. But anyway, when you divide the entire globe into the regions and the regions into data centers, you have the availability zones. But who will drive that networking? That driving of the networking will be done by the VPC, Virtual Private Cloud. This is a network element. By default, you already have for each of the regions. There are so many regions, okay, all over the world. I think it is more than 50 regions, 53 or something, 53 plus regions all over the world. Okay, in India, we have Mumbai and Chennai, I think. Mumbai and Chennai, yes. Two regions. Hyderabad Hyderabad data center is coming up for AWS. Or I think it is already done. I'm not sure. So why do we divide your things into regions? Why America is divided into 50 states? Why India is divided into 32 states, including the union territories? UTs. It is because for the better governance, isn't it? Do you agree? You are quiet. Why? It is because of the better governance. You want to govern them properly, govern each and every state. So because the United States is a big state, so you have divided it into smaller states so that the governance is better. Similarly, AWS has divided the entire world into 53 or more regions so that it can be, so they have put into each of these regions the data centers, maybe 3 or 5 or 6 or 8, depending on the size of the region. So in India, right now there are 2 regions. And say in Mumbai, there are 3 availability zones or 3 data centers, which is also called subnets. So you learn about subnets, VPC subnets. So a VPC will be divided into subnets. By default, one VPC will be divided into 3 subnets or 3 availability zones. for the 3 data centers. Then you have the elastic load balancing. You have the Amazon Route 53. What is Amazon Route 53? It is a service which will give you the domain. Like you go for GoDaddy or for the Google Cloud domain services. Okay. Similarly, for Amazon, they give you Route 53. So Route 53 will give you because you do not want to expose your IP address to the world. So you go for a domain. And who will give you the domain? What is the domain architecture and all those? How do you implement your domain? You will use a service of Amazon called Amazon Route 53. Then there is AWS Direct Connect. So these are the connectivity tools and networking tools that we will learn in our main course. Any questions up to this point? No question? No question is a very good thing. So for me, I understand that you have learned. So let me proceed. So I am not going to details of this infrastructure, but I will show you a diagram. This is the diagram. So it's a very, very common and very much when you attend the meetings. Why we are learning all these things? Because you have to, when you are in a company, you will be attending a meeting where your DevOps guys will be talking some language, your solution architect will be talking some language, your developers will be talking one language in some language, your manager, project manager will be talking some language. But you have to be aware of these terms. These are the terms which are very, very often used. Okay, somebody is saying it is an on-premise what or on-premise services. Somebody is saying infrastructure as a service, IaaS services, platform as a service, and then software as a service. What are these? So think from the AWS perspective. This organization has not gone to hire any of the services from AWS from any cloud provider. So they are managing everything starting from the networking to the application. All these layers are getting managed. So you say your applications are all on premises, your servers are all on premise, or your middleware, your operating system, your storage, your networking are all on premises. Got it? Nothing was given to some third party to manage. Now we come to the infrastructure as a service. So I did not discuss this because this is a definition, but we want to understand it from this diagram. What is it? When I say infrastructure as a service contains the basic building blocks for cloud IT, it is a very vague, though it is coming from Amazon only. It typically provides access to networking features, computers, a virtual and dedicated hardware, and data storage. IaaS gives you the highest level of flexibility and management control over your IT resources. It is more similar to the existing IT resources with so many. Did you understand a single word? Did you understand what it is trying to say? So if I go there, and now if I look at this diagram and see that, okay, I understand now. The company has given the virtualization, server, storage, networking, because it found that it is too difficult to manage for themselves and hiring experts from the OEMs. OEMs are the original equipment manufacturers. So it can be Dell, it can be HP, it can be IBM, it can be anyone. So to manage them, they take a lot of money out of their pockets. Okay, so a company has to spend a lot of money for the AMC, annual maintenance contract, for hiring the resident engineers to maintain the server, storage, networking. It costs a lot. Apart from all this, still something is going wrong with the storage, something or the other. Every day something, some issues happen with the servers. Okay, servers getting down, virtualization is not working, networking having lots of problems. So the company is really bothered. The company is really spending a lot but not getting the equivalent services. So what the company decided that, okay, this 4 layers, I'm going to give it to the cloud, AWS cloud. Okay, they are the champions, they are the experts. And really, believe me, from the day these 4 things have gone to it is called the infrastructure. Basically, it consists the infrastructure. Networking, storage infrastructure, servers infrastructure, virtualization. So all these things, once it has gone to AWS, what happened was there were no complaints. The user experience was fantastic. Then I will say, okay, I can devote my resources to manage the OS, the middleware, the runtime, the data, and the application. I don't want to give my data and applications because this is very, very private to me, and I have to ensure the security of the data and the applications. Okay. So this type of getting the services from a third party or from AWS is called infrastructure. You have given this infrastructure for a better management, and you are hiring the services of AWS. So it is called infrastructure as a service. Now, coming to the platform as a service. Now, even after this, you find your resources are not being able to manage the 3 layers up to the runtime. The operating system, which is every now and then it is giving some problem, because AWS will not manage your OS, because according to your agreement as infrastructure as a service provider, they are not going to help us with OS, middleware, and runtime. So company is still having some lot of investment on these 3, but not getting enough good service. So what they decided that OS, middleware, and runtime as well, they want to give it to, because they were very happy with the infrastructure as a service of AWS. So what they did, they have given up the entire platform. 1, 2, 3, 4, 5, 6, 7. 7 layers of the platform to be managed through AWS. So are you getting me? So only 2 things are left with them, the data and the applications. They don't want to part with the data because of the security issues and applications. But at one stage of time, the data is going so large, and the database operators and the database managers and database administrators are so costly that, and also it is not helping, it is not solving the problem. Day by day, these things are getting worse and worse. So the last 2 things that were very private to this company, now they have decided, based on the performance of AWS, because they were not getting a single escalations any day. They were very happy, and because of AWS being a very secured, they will implement all the securities to maintain the data and the application. So the security as well and everything is ensured, and you have given it. And in doing so, it is calling the software as a service. So you have AWS is now your SaaS partner. So AWS is partnering with the company as a SaaS partner. So everything that is managing, even your mail servers, the mailing, your inventory, your everything, whatever is needed for storage, your server maintenance, your middleware, everything will now be under the purview and management of AWS. So you have given the entire software as a service. You are hiring the software as a service from AWS. Is that clear, or you have any questions? Please let me know, because these 3 and 4 terms are very, very important. Any questions from anyone of you? Is anybody there? I doubt. Mr. Menon?
Now we're here, Mr. Debashish.
Oh, okay. Great. I thought nobody's there. Fine. Thanks. So let me go back. Okay. So as I told you, these are the various services, which is one of them is the most important and a very popular service called Elastic Cloud Compute, which is a virtual server in AWS. So you are creating a virtual server. Why virtual? Because it is not tangible. You cannot see that server. You cannot touch that server. You cannot break that server. So many things. But the server is always available to help you, to serve you. Okay, it's a virtual server maintained over AWS cloud. EC2 is the basic fundamental block around which the AWS is structured. So without an EC2, most of your services are, there is no point in getting most of the services because everything is around pivoting around the server. You do everything on the server. EC2 provides remote operations on virtual machines infrastructure. A single virtual machine is an instance. We say EC2 instance. This is a popular term. We do not say a server. We say EC2 instance. Instance is nothing but a server. Okay. So we can also define the size. We can define the size, and that size can be starting from a micro to a large, a 2x large, or it can go up to a big machine. You can go for hiring. But when you do this, it's micro. When you open an account in AWS for 12 months, you are in a free tier category. That means you will not pay for anything of your usage. Yes, there are few resources which are getting will be costly, or which are going to, you have to pay some money for the services that is provided, like the Elastic Load Balancer, like the Elastic IP. Elastic IP is the IP address, but that is a constant one. You can assign it to your EC2 instance. So those parts. So you will say, how can I create a server with an IP address? Yes, those are public IP address and a private IP address. That will be automatically generated and given to you. It will be no cost. But if you, because the public IP address keeps on changing as you shut down your server and start it up, the next time the IP address will be, when you start it up, a new IP address will be generated randomly from AWS. So every time you will have to connect it, you have to connect it with the new IP address. Correct? So most of the services that you use during your free tier period of 12 months will be free of cost. So it is a nice bet because Azure is also a good platform to start learning cloud, which is from Microsoft. But Azure has 1 month of free service, like $200 free for 1 month. But after the rest of the 12 months or 11 months, you will have limited number of resources which are free. Most of the resources are chargeable. So in that case, I will always start to learn a cloud through AWS because I will not spend money from my pocket to learn a subject, like very popular subject. And this is a subject without which you cannot enter the IT domain. Okay. So basically, the size I will be learning the entire course of ours, which is our job ready training, is entirely based on micro instance. That is the size. A small size is enough for our learning, and that we will see. All our tools, all our DevOps tools will work on a micro size of an EC2 instance. The EC2 micro instance type is the least reliably provisioned. Leave it. For our learning, yeah, it is very small and it is not, it can crash anytime because it is only one virtual CPU, one CPU, and 1 GB of internal memory. So it is very, very small. Your laptop is having 16 CPUs, and it's a very powerful machine, and it is having 128 GB of internal memory. Can you believe? So powerful. In comparison, you are creating a server, but server is not only how many CPUs you have, how much of memory you have, or how much of storage space you have. It is not that. It is whether your server is resilient, robust, highly available, and can be replicated. So these are the features which make your laptop different from your AWS cloud server. AWS cloud servers are much powerful than your laptop because of these 4 features. Okay, even if they are small inside, but it is much and it is more than enough for our learning cloud. Any question? Amazon machine images. Like you go and you have got your laptop. Now, when you start your laptop, you cannot see that you do not see your laptop starting up. Why? Your laptop will not work. Your desktop will not work unless and until you have installed your operating system. Because all the devices, all the peripherals, and all the things that you will be managed is through the kernel of an operating system. So you need an operating system for any server, and that you have to install it into your laptop. But in an AWS cloud, when you create an instance, an EC2 instance, you just attach. You do not have to install an AMI. So that concept of image is coming from containerization, that is Docker. We have not discussed about Docker. We will do it. So then the later session on latter half of this cycle. So you will see what is an image, what is containerization. Okay, so think of it like it is a ready-made sort of a package which is just attached to your. It's like a plug and play. You do not have to install it. You just attach your image into your virtual machine or EC2 instance. Your server is ready with an operating system. Isn't it magical? It is magical. And when we practically see it, you will see within 2 minutes, you have created, not even 2 minutes, within half a second, half a minute, you will see your server has been created. Can you believe? Earlier days when we used to work in IBM and all those things, when we went to the war room, and there you will see a server getting installed by the HP engineers, and that is taking almost 15 days, almost 20 days to get everything ready for a server with the storage, with the networking, with an operating system. 15 to 20 days. Can you believe? And you are installing a very powerful server EC2 instance without, not even in a minute, with all the Amazon machine image. So you can go for any underlying image. Image is like your operating system. It can be Ubuntu, it can be Red Hat, it can be any flavor of Linux. It can be SUSE, it can be Fedora, it can be Kali Linux, whatever Linux you want to, Amazon Linux. Okay, so any flavor of Linux you want to go to CentOS, and you can go for installation of, not installation, AMI of Windows or Mac, which is all available as a package. You just attach it. Okay, so this is how simple. So you will attach even the EBS, Elastic Block Service, which is the block volume, whether it is 20 GB or 50 GB or 120 GB of hard disk of SSD type, while you are creating your image, your EC2 instance. It is as simple as that. Clear? If time permits, I will show you one quick demonstration of how we create an EC2 instance over a cloud, AWS cloud, if time permits. Elastic Block Store, as I told you, It is a block level storage, volumes for use with EC2 instances. Use them like any block device, like a hard drive. It is a hard drive, you can say. But everything is over the cloud. So this service is provided by the cloud. It is like a service. You are attaching a service of storage into your instance. It can range from 1 GB to 1 terabyte. So in one instance, you can attach 1 terabyte of EBS. So EBS volumes are network attached and persist independently for the life of an instance. So it is automatically attached to your VPC, your subnet. Okay, you do not need to do any further activities. You will see how easy it is to create a server over the cloud. EBS snapshots. Now, EBS provides the ability to back up point-in-time snapshots of your data to S3. Now, you can do a snapshot, but again, this particular thing is the cost part. As I told you, there are a few services which are not in the free tier from the very beginning, like the EBS snapshots. What is a snapshot? Is that for every the end of the day, you take a point-in-time snapshot or a backup, you can say, and put that journal into the S3 bucket. So next time, what will happen is you will just keep on snapshots for incremental backups. That means what you have done yesterday and today you have done something more, some more data has come into your system. So you will not take the full backup, you will take the incremental backup, and that is called a snapshot. Only the blocks on the device that have changed since your last snapshot. So again, you have a point-in snapshot of the incremental backup and you store it in your S3. So someday, suddenly you see your system is not getting up. It is not booting up. Okay. So what will you do? You just go to the last snapshot that you have taken and saved, and you use that snapshot to recover your system. Okay. Isn't it nice service? But this service comes with a cost. Simple storage service. This does not come with a cost, but it is one of the world's most popular one of the services. Okay. Simple storage is a minimalistic data hosting service. Storing data and downloading data in S3 are built separately. Yeah, of course. While you create a service like this, you will not be charged. But once you start using it, it's very minimal, but there is a charge, even if you are in a S3 bucket. But for your learning, when we learn in our course, you will not be charged because we are not using the data. We will load the data and we will remove the bucket. That's all after our session. So we will never be billed. If you keep like you have kept your photos, files, so many files and you are every time updating your files and using the S3 for each usage, you may be charged a bit, very, very less, very nominal charges. It is like 0.01 cent per hour. It's very, very nominal charges. That's why cloud is so very popular. Acha. This is one more important thing. S3 can host only static data. It cannot store dynamic data, like it cannot host your dynamic website. So your S3 is appropriate for hosting some static web page, like no server-side processing, like your company's welcome page. What you can do, you can host it over your S3. So every time you need to call that static web page, and that is it does not need any server side, because your company welcome page, like your company's products or company's profile, will not change every day. Does it change? No. It is not like a weather forecast. Weather forecast is going to change every hour, every day, every week, every month, every year. So these things are dynamic. So you cannot host a dynamic web page over S3. That is one limitation. But people do not use S3 for hosting any web page. But it is very, very good for hosting large files, like the images that you build, like the operating system. Operating systems can be 1 GB, 2 GB, 3 GB in size. You can put them, prepare the operating system and put them as an AMI, as an Amazon machine image onto your S3 bucket. Elastic Load Balancer. Now, this is a service which is also not falling under the free tier quota. Okay, it will be, if you are using it, you have to be prepared for the charges, because Elastic Load Balancer is a costly service. Not costly as you think. It is very, very less price, but it is still priced. The ELB service is solely for managing home incoming network traffic to your instances. So it is like a load balancer. So many traffics are coming into your application. So you have your application, okay? This is your server, and there is one application running inside your server, and there are lots of traffic. The traffic is increasing day by day. Earlier, it used to directly hit the application. It used to hit. But now you have installed a load balancer, Elastic Load Balancer, or ELB. Between the user, so you are the user. There are millions of users giving requests, okay? So you are the actors. You have installed a network load balancer. This can be also a server, a small server having the Elastic Load Balancer technology. So that can act between you and the application, such that your thing will be distributed between the applications. Now, application, this is your application, and there are a number of replicas, the pods for microservices. These are microservices. And when we learn Kubernetes or Docker, you know that your application, you have put it into a container. These are the same application, let's say Java application. So all of them were hitting the first application, but no, with the Elastic Load Balancer, you have distributed one request over here, another request over here, another request over here. So you are distributing the load. That is what it is called, Elastic Load Balancer or load balancer in general. There can be a network load balancer and then Elastic Load Balancer, all coming from AWS. Okay. The algorithm will be a bit different with a network load balancer and with an Elastic Load Balancer. But Elastic Load Balancer is much more efficient than a network load balancer. So that is called load balancing. Any questions you may have? I'm browsing it through because. So this can be Elastic Load Balancer. Fulfills a vital role that you could implement yourself using some dedicated EC2 instances. So between the EC2 instances, between the servers, you are revolving between the servers. So either between the applications within the server, or you have multiple servers where your application is distributed. The same application is distributed over 3 servers, 3 EC2 instances. Server 1, 2, 3. You have application 1, the same application 1, the same application 1. They are distributed over the 3 servers. So when the traffic comes, so the traffic will not decide which server it has to go. It will be decided by the load balancer. Load balancer may distribute this traffic to here, or here, or here, depending on some round robin logic. R, L. Okay. No questions? Any question? So there is a use case of, I'm not going to the details of EKS. EKS is the Elastic Kubernetes Service. Kubernetes is a different topic. We will have a discussion of Kubernetes in the last 2 sessions of our cycle. Okay, so I will hold that discussion at this. So this is a Elastic Kubernetes service. So you can implement your Kubernetes, or you can take the services of AWS called Elastic Kubernetes Service. So an ELB can use or distribute the traffic coming from the EKS data and can distribute between the applications or the pods which are running inside that EKS cluster. That is a use case. So we can go ahead. So as I told you, there is a dynamic. So this is the database part. So database part, you can have DynamoDB is a fully managed NoSQL database. Like there is a flexibility of the data. There is no schema. There is no structure of our database. So that is very important. Your message, your SMSs, earlier SMSs will be called a structured or unstructured. Can you tell me your SMSs? Or you are writing a mail. Mail is also a data. Okay. So are they the alarms, the alerts, the mails, the SMSs, the messages? What are they? The notices. They are also part of the data, but are they structured data? Can you query an SMS like normally? No, because they do not follow any structure. So those type of data is also a data, but they have to be queried and they can be managed through NoSQL database. Okay, sorry, NoSQL database. So like a MongoDB type of things, but this is very, very well handled by DynamoDB. Automatically replicates your data. So it's a managed database. Replicates your data synchronously across multiple availability zones within an AWS region to ensure high availability and data durability. So these are the ACID properties of any database. Okay. Designed for extremely high throughput and low latencies for both reads and writes. So it's very, very fast in operation. With respect to RDS, people are moving into either MongoDB or DynamoDB because they are very fast in performance. One of the reasons in comparison to RDS.
No, may I ask a question, sir?
Yeah, sure.
Okay. Can it ever happen that let's say you're deploying or you're building an application and then parts of the features of that application that you have, it requires NoSQL database, non-relational, and you also have features that require a relational database. My question would be that, can it ever happen that you have a situation where you deploy both of those kind of databases, or is there a provision of some sort that you must take into account?
Yes, very much. See, the legacy type of applications, like as Karthik was saying, those bank type of applications, insurance type of applications, okay, they will always go for an RDBMS because they have a known pattern of data. Okay, so whenever you have a known pattern of data, when there is no surprises, you can store it in a structured way. Then you have an application where you go for RDS or RDBMS. Okay, sort of an application. And another part could be a very, very recent type of applications which are using a lot of highly unpredictable type of data. So like the messages, like the mail, you have to also predict them, or you have to query them. You have to do some processing out of those data as well to get some, like you bought something on a cloud platform, or say on an e-commerce platform. You have bought something. Next day, you will see that that platform is giving you messages that, sir, you bought this thing, and we know your preference that you bought a Nike shoe. Okay, so this is another range that we are also offering, that is assets, shoes. So that is how do they know? Because they have now learned about your preference. So something which they didn't have. They didn't have your history of preference of liking or dislikes. Now they have some data. They have analyzed your data. So how do they do it? They didn't have any pattern, but they could do it through some queries which was available through NoSQL queries, or no structured queries. So that application can have, see, you are making a payment. Payment have to have a pattern. You cannot be unpredictable that your payment may reach or may not reach the customer. Okay, so in that case, you cannot go for a NoSQL database application. But for that particular, when you are trying to build up the customer profile, that sort of a thing is unknown to you at the very beginning, but gradually as you use, your profile becomes known, your taste, your this thing. So you will use NoSQL sort of database at that particular part. So a big application is always having a mix of both structured queries, structured data, and non-structured data.
Oh, so it'll be very wise to start with the NoSQL and then over time migrate to a SQL database.
See, if you are doing a NoSQL database sort of a thing, then always that means it is no structure. There is no structure, particular structure. You cannot change it from a structure, no structure, to a structure. There is a different set of application which is using a legacy sort of a database or legacy set of application. So your application can have a mix of both the old world and the new one.
Yeah, because I was actually asking in terms of seeing that the sort of paid services. So like to minimize the cost over time. Because of course, yes, we have to start with NoSQL. Then once we have a sort of like a structured, once we know what the customer wants, so eventually
Exactly.
yeah, because I was asking from
that is
like
you see that is how you increase your product portfolio, because initially you didn't know, you had a set of fixed set of products, okay, that you started your company with. But as you get the feedbacks from your customer that I want this sort of, this is good, but I wanted this sort. So this is your feedback. That feedback is a non-structured data that was analyzed. It's sort of a big data. It was analyzed through some different tools like Hadoop and all those things, and therefore it got a result set that says that, okay, we should introduce this sort of a product. So you are making your product portfolio bigger and bigger and bigger. You are catering to larger segments of the customer.
Okay. Thank you, sir. Thank you.
Thank you. So as I told you, it is a very, very relational database with automatic backups, patch management, because they are doing the managed services for this relational database. It is a SaaS application, software as a service. So they are giving you a service, the full service of managing a relational database over the cloud. So AWS is giving that RDS service, and therefore your native access to an SQL database, as if you are accessing a database as per your query. So any sort of query that comes out of your SQL queries, structured query language, you can apply that structured query language over this. You know, in an SRE, you get why the SRE people are in demand in the organization, the operations guys. The operations guys who does not know SRE can become obsolete tomorrow. But an operations guy who knows about SRE will be very much in demand in the future years, because this guy, both guys can look into the log files, big log files. For the applications running, large number of applications running, they are generating the log files. And there is monitoring tools. There are monitoring tools like Logstash under the SRE, Logstash. Okay. And then Kibana, you are producing that on a dashboard, on a graphical dashboard called Kibana. So all the log results are getting interpreted into some dashboard called Kibana. And then there is the most important part is the elastic search. Because you see, these log files can be of 1 GB of data, huge files. And how can you, these are all unstructured data. This is not like a table that you can predict. A log can be the errors, whatever as the applications run, the log files are generated. These are very, very, very much unstructured. You do not have any pattern. But with the help of Elasticsearch, first of all, you have to find out a particular error which has happened of a particular time in a particular thing. So you will use Elasticsearch tool, which is falling under SRE. Okay. And then you use basically, first of all, there is a Logstash, which will help you to, to break this unstructured data into a structured data. This is the magic. So lots and lots of log files, which is unstructured data, will be converted to some sort of a structured data. And then the Elasticsearch can work on this structured data and produce the data for analysis more like a dashboard on the Kibana graphical interface. So just the operations guys have to produce their whatever the metrics that they want to watch, monitor on the dashboard. So if an operations guy knows all these things, can you believe what their demand will be? And on the top of that, as Karthik was saying, if they know cyber security, how to also apply some tools of cyber security to check and secure the data on the log, and how to understand whether there was a hacking, or there was some security violation or the security vulnerability on those studying the log. Log is very important part of your monitoring tool. So all these things are done through the SRE. So you see, knowledge of database is important, but you see this one will always give you all the management utilities of managing your database. So the automatic replication, automatic patch management, automatic backups, all this will be done. So this is there. But at the same time, you can use your SQL knowledge to query the database, create your data, and do whatever you like. Okay. Similarly, if you have a knowledge of SRE, you can, of course, do with the NoSQL part of it. Because the logs are very, very unstructured. How you will convert your unstructured data to a structured data such that your Elasticsearch can be 100%. And then you produce this on Kibana or Grafana. There people use also Prometheus. So I will proceed. So as I told you, Amazon VPC, this is a diagram. VPC is just a Amazon Virtual Private Cloud. Gives you full control over your virtual networking environment, including resource placement, connectivity, and security. Everything. So the entire network baseline is provided by the virtual. Without a VPC, you will not be able to work on a cloud on any region. Get started by setting up your VPC in the AWS. So either you set up your own VPC or you can use the default VPC, which is provided for each region by AWS. There is already a VPC provided to you. So you can start right away creating your instances. Or if you want to have your own VPC, you can create that as well. Because most of the companies would like to work on their own private virtual cloud. They don't want to use the default VPC because that is not very safe. Not safe, I mean, it is very safe, but the latency can vary because this VPC is getting used by the other accounts as well. Other accounts means there are millions and millions of users accounts who are in a particular region, like Ohio, like North Virginia, like Mumbai, like Singapore. So it is not only me. Yes, it appears to me that I am only the owner of that VPC or for that account. No, this is not the truth. Then so you can create your own VPC, then it's fine. And you can have your own subnets. You can have your own that is you are expanding your data centers. You are having your own data centers. You are having your own EC2 instances on those data centers that you produce. So basically it is saying that you are in region 1 and you are in region 2. So you have created your Amazon EC2 instances on region 1. So you already have your VPC subnet in AZ1. So availability zone 1, this is one data center. This is one data center. In the same region, in the same default VPC. Here you have the two availability zones. Availability zones are nothing but a region. Region is divided into availability zones. Availability zones are accessed over the network through subnets. You remember this at this point. So that subnet or this thing is availability zone 1. So you created two instances, two servers on availability zone 1 of region 1. And then there is availability zone 2. You have created another two servers. All these servers can communicate with each other within the region, there is no problem. Here in this diagram, we have two different regions and they can interact with all the availability zones and all the instances created over the availability zones. But there is no interconnectivity. This is one use case where you have two separate regions where they are securely working within each other, but not across the platform, across the region. But you can go for a hybrid sort of connectivity. Like one region is also communicating with the other region. So this EC2 machine or this server can communicate with this server in a different region. That can also be possible. Now, Elastic Beanstalk, where does this service come? Remember, where did we see this service to be appeared on that application partitioning that we have done, like the foundational service, the application service, and the management service. In which plane did it appear? And what is this service? Did it appear in the foundation service, or in the application layer, or in the management layer? Do I need to take you back? Let me go back. So we are on this management and administration layer on which you find the deployment and automation service under which you have this particular AWS Elastic Beanstalk service. So what is that? You do the deployment and automation. So let me go fast over here. Yeah. So here we are, Elastic Beanstalk. So this is a very, very, this is also, this Elastic Beanstalk is not under the free tier, first of all. If you need to use it or do this at with the expectation that there could be some charges in your bill. But to learn it, it is good. You have a Java application. What is the Beanstalk doing? Well, you want to deploy it very fast. And you want to do all those. See, you have embedded within the Java application, there is the web application with the environment configuration. Everything is packaged within that application. You do not need to worry about this. The developers are given this. But the want of the project is that it should be uploaded. It can be distributed over any of the EC2, basically deployed, or EC2 instance, and it can be enabling the Elastic Load Balancer. So there can be multiple. So this Java application will be distributed to multiple instances. So there are five servers. You want to have the same Java application distributed onto all the 5 servers because they are in a cluster of a network where all this, maybe you can say that there is a Kubernetes cluster on which there are 5 nodes with a master node. Okay, and you have deployed your Java application, which is a microservice application, over as pods over onto all of these servers. You want to do it yourself. So you will take a lot of expertise. You need to know Kubernetes. You need to know so many other things. Okay, how to deploy it, how to package them through Maven and Docker into an image, and then deploy that image over onto this. So over the pipeline, all these things are not needed. You hire the services of Elastic Beanstalk. You upload this one into the Elastic Beanstalk. Elastic Beanstalk will do everything for you. You wanted 5 servers to be distributed, so this Java application will be distributed over all the 5 servers. Okay. Now, see, if you are distributing over the 5 servers, that means you need a load balancer. So this load balancer will be installed, or rather implemented along with the Elastic. So Elastic Beanstalk will do everything for you. And also it will say if there is a huge spike in the usage, so it can apply the auto scaling. Everything is inbuilt within the Beanstalk. So can you believe that your days and days of work has been saved within minutes? You just have to do one manual activity, or not even that. You can put your application into a pipeline as a job, and that pipeline can trigger this particular upload and put that into an Elastic Beanstalk. Any question? So why Elastic Beanstalk? Elastic Beanstalk is a service for deploying and scaling web applications and services. Upload your code and Elastic Beanstalk will automatically handle the deployment. From capacity provisioning, that means you know that you, instead of 1, you will distribute into 5 using the Elastic Load Balancer to distribute the traffic, as well as there is an auto scaling. So for capacity provisioning, load balancing, and auto scaling to application health monitoring. So the health of the application will also be monitored. So isn't it multiple facets, multiple features in one service? So people are going for those. Why to hire expertise with so much cost? So we have the service automatically built for you. Use them, hire them. It will be much less costly. So cloud formation is something like in our AWS classes, we teach about AWS cloud formation, but practically we learn Terraform to do all the provisioning over the cloud. Okay. Yeah, we also learn cloud formation. Cloud formation is to speed up cloud provisioning with infrastructure as a code. But infrastructure as a code, we will always use Terraform, and a company always likes somebody who knows Terraform to do infrastructure provisioning. Okay, so like creating your S3 buckets, you're creating your EC2 instances, creating your VPC, creating your subnets, all these things you will try to provision. That is with the Terraform, not with AWS Cloud Formation. Today the company has gone for AWS. So fine, you know Cloud Formation, you can use the templates of Cloud Formation and you can provision it. But then tomorrow the company has decided that you might go for Azure as well. So they are decided that few features from Azure services is good, better, and few features from or services from AWS is better. So what they will do, they will have a combination of both the clouds. So in that case, they might not go for cloud formation. So if you want to provision some resources over cloud, AWS, and some resources over Azure, so you will not use cloud formation, because cloud formation can only work on AWS. Cloud formation cannot work on Azure. Like similarly, the bicep, which is almost the same as cloud formation on Azure, cannot work on AWS, but Terraform will be able to work on. Create any of the resources that you want on any of the cloud. So therefore, though we will learn about cloud formation, but we will give importance to learning Terraform as well. AWS as an identity and access management, that is good. We will create those users, and we will create a group, and we can assign the policies. Okay, so let's say this user is not from a development background, or maybe this user is a developer. I will create, and this user needs a service called Lambda function. So Lambda is a AWS service. So to enable this user who is a developer to have an access to the Lambda services, we will assign a Lambda privilege onto the user. So you can see that I have created that a particular policy for that user. Okay, and then I have allowed, the effect is to allow, and what is the thing that is being allowed to? It is the Lambda. So that developer, that particular user can create the Lambda function. So whatever resources are required to support the creation of a Lambda, so resources star means all the resources. So this person has been specified or given a role of using Lambda function, the service of a. If it is not given, so that user will not be allowed to. If he tries to create a Lambda function, it will get an error. So identity and access management is a very, very important functionality or a service provided by AWS. So who can access what? This will be defined within the identity and access management. Who can access what? What means the resources. Now, I think, Mr. Menon, are you there?
Yes, I am here.
So, do you want me to let them know how fast we can create a server and how can we create immediately and access that particular server from Windows?
I
If
it is
not too much.
Yeah, that's the thing. So guys, what is your thought? Should we start with the hands-on on AWS? Because this DevOps, we have
Not
8
AWS
weeks.
in all, just a part of AWS, that is how to use that EC2 service. How to create a
I think
server
we
very
can.
fast.
Yeah.
Just a small part of it. because somebody wanted to have a combination of theory, because unless we know the theory, it is very difficult to go for a lab.
Yeah,
So
true.
just because we have covered almost like 1 hour 40 minutes, so if we can use another 10 minutes to just
Yeah, that will be
see.
great.
Okay, thank you.
Guys, do you have any question? Feel free to ask.
Hello, I can see my picture frozen. Was it all through like this?
No. Just it is happened. Like,
Okay, no problem. So let me go to my AWS console. See, this is the AWS console where I have already created my account, and therefore I am being able to sign in. I will sign in. No. So how to create an account and all these things are part of our main course. So we will learn that. This is DevOps trainer. This is one of my IAM users. Okay. This is an IAM user. Can you see? And I'm logging in as an IAM user. I'm logging in as an IAM user. So I'm signing in. And here there are lots of services. You see, there are lots of services. And within each of these categories, like in the compute category of the compute service, we have an EC2 service, right? So we go to EC2. So there is a dashboard presented to me. I can go in for lots of discussions, but right now I'm just showing you how fast we can create our EC2 instance. So I am in the Mumbai region. There are so many in the United States. You have North Virginia, Ohio, North California, Oregon. So each of these regions will have a region code, and each of these regions will be having availability zones. And the availability zones are nothing but the subnets, the data centers. One of them is my Mumbai region, AP South 1, Asia Pacific South 1. I'm going to this. Oh, because I'm already in Mumbai. So you can easily go from one region to the other region, Singapore. So you can see I have gone to my Singapore region. So the default VPC, any region will have a default VPC, and they will be having the zones, availability zones. I'm not going to that much details. I'm quickly, and I will switch back to my Mumbai region because I have the key pair created already there. So I will go to instances. Right now there are no instances created. I will quickly, instances means the EC2 instance. I want to create it fast. Launch instance, I gone there. I am naming this internship server. You can give any name. And now see the beauty that OS means operating system image. And just as I told you, I can just attach one Amazon machine image. I want to attach one Ubuntu image. Ubuntu is one of the Linux servers. Like you have the Red Hat, you have the SUSE, you have the Debian, and there are lots of. These are the quick start few machines they have suggested. You can also go for a Mac. You can also go for Windows. But I am preferring to have a Linux instance. 24.04 is the LTS long-term support version. I have attached this architecture, and then I'm selecting the size of my computer. Okay, it is T2 micro. It is lying in this free tier eligible. So I'm using a T2 micro, small, 1 VPC, 1 V CPU, 1 virtual CPU, 1 GB memory. It's a very small machine, but it's okay. The key pair is a part of authentication. You will not be allowed to get in access this without a key pair. Key pair is like your fingerprint. It is actually a fingerprint. So I already have created, or else you can create a key pair. But because of my time constraint, I have already created a key pair for the benefit of this. So the key pair name is DevOps dash internship. This is the key pair. So this is of type RSA. This is the type of encryption for security. So this is my fingerprint. I've attached my fingerprint. So nobody can have an access to this EC2 instance. It is secured with the help of a key pair. So somebody who does not know my key pair will never be allowed to access. Now this is the default VPC. I'm not changing anything. The subnet, no preference. Let AWS select me one data center for me, the availability zone for me. And the auto assigned public IP is enabled. So I will have a security group. It is like a firewall. I'm creating a firewall. Those who have attended the security, cyber security session the previous weekend, you know what is a firewall. Karthik was excellent, brilliant when he had given you all the details of SSH firewall. So I'm attaching a security group into for the security. I'm fencing. I'm giving a firewall fencing around my server. Okay, I'm selecting a security group. Let's say I'm selecting this launch wizard 3. Some security group that I have already created. Security groups are nothing but some rules. The traffic, if they're coming with that rule, following that rule, the traffic will be allowed to inbound connection. And then I'm storing some storage for this one, which is 8 GB and GP3. This is the general purpose SSD. SSD means your solid state device. It's a hard disk. So I'm attaching a hard disk. I can go up to 30 GB within my free tier eligible. So I will quickly say launch the instance. So now your server. So you see, within not even half a minute, it is a few seconds. You have created your server. And how do you verify that? You go to your instances, you refresh, and can you see your server is by the name internship server, and you have your public IP address and a private IP address. This will never change because it is the internal IP address. But this is going to change every time I shut down my server. Okay, I will pick up this. Can you see if I go towards the right, it is of the size T2 micro. It is in the availability zone AP South 1B. I have not selected this. This was automatically selected for me by AWS. This is the public IP generated randomly, and this is the security group, and this is my key pair. This is what's the time, and this is the platform is Linux, because my operating system, the AMI was Linux, Ubuntu Linux. So what I did, I copied this public IP address because I need a public IP address to go into that thing to access this computer or the server. So I will use my PuTTY, and I have a session. I will load it, and I will put only my IP address. This IP address is the same IP address of this particular server. So I can save it. I will open it. I know you may not follow how are you connecting. Basically, I'm connecting my Windows. I'm connecting from my Windows. Connecting from my Windows into the server on my cloud. So can you see? I have connected as a user called Ubuntu. This is the Linux. Okay, you are using Ubuntu Linux. So you say you are having this internal IP address. Okay. IP address that you have copied from here. Here. This was the public IP address. This is going to change every time you shut down and start up. But this is not going to change because this is a private IP address. The icon name is computer virtual machine. It is actually a virtual machine. It is the machine ID, the boot ID, virtualization, Zen virtualization, Ubuntu. Can you see the server version 24.04 LTS? It is the Linux kernel is Linux 6.8. It is the Zen hardware vendor, HVM, highly available virtual machine, and firmware version, whatever. It has given all the utility. So I will end my discussion today, and we will appreciate how cloud has made our life so very easy that we can create a server with, my God, believe it, and with the operating system. Not even, I did not install the operating system Ubuntu. It was just attached as an image. That is the beauty of containerization that we will learn in Docker session, right? So if my server is ready to be used, I can use it. I can start using it. Okay, so I know all these things are hidden. Anyway, that is all for today. Thank you very much for your patience. I know you have started from the last 4 hours. It is not an easy task. Not an easy task for all of you on a Saturday, maybe morning, evening, or afternoon from various zones of this world. Thank you very much. Oh, my camera is gone. No problem, no problem. So, Mr. Menon, this
Yeah.
is all for today.
Okay, thank you everyone. So guys, do you have any question? I think we are done. And next day we do have some hands-on, right, Mr. Debashish?
Next day we are going to start with the GitLab, the pipeline. But the pipeline can only be demonstrated with some tool like Terraform and Ansible. So what we will do, we will have a bit of the knowledge of GitLab and Terraform. So we will have mostly theory. So on the next weekend we will have a full demonstration. It will be no theory, because we will learn to create a pipeline and use the certain jobs of Terraform.
Perfect, perfect. So yeah, guys, I think we are done with our DevOps session and cybersecurity session. I feel we are going to create a poll. So we would like to know about your feedback, how you like, if it is at all helping in your journey or not, or just share with us. And if you need any kind of guidance, if you have any question, feel free to ask. We will happy to help. Okay then. So
thank you,
Ernest. Thank you, Sion.
In fact, thanks everyone.
Yeah.
And
So
it's really not a matter. It's not a matter.
Yes.
To have such questions for 4 hours.
Definitely. And please remember the DevOps, this whole program is 8 weeks. So first couple of sessions are a little bit theoretical to make sure that you guys are understanding what we are delivering. Then we are going to demonstrate slowly, little bit on a hands-on. So you will have a high-level overview about your your day-to-day activities and about the domain-specific knowledge as well. So see you next weekend. Meanwhile, if you have any question, feel free to ask in the group. Have a great rest of your weekend and happy Thanksgiving.
Happy Thanksgiving, Mr. Menon. Happy Thanksgiving, Mr. Debashish.
Thank you.